Hi guys, it's me again. So, in our previous video, we have solved problems regarding exact differential equations. But what if when we tested for its exactness, it does not come out exact? Now that is where the integrating factor will come in. So, the integrating factor is simply equivalent to e raised to the integral of a function. So, our two result is expressed as these following rules. We have 1 over n, if 1 over n times the partial of n in terms of y minus the partial of n in terms of x is equals to f of x, or if the function is x alone, then our integrating factor is equivalent to e raised to the integral of f of x dx. Then, if 1 over m times the partial of m in terms of y minus partial of n in terms of x is equals to g of y, or if the function is y alone, then our integrating factor is simply e raised to the negative integral of g of y dy. So let's proceed with the examples so we can further emphasize the concept of these integrating factors. As usual, I have here two examples that I have already solved, and I'm just gonna explain it to you guys how I come up with the answer, or what process I use to get the answer. Okay, so in our first example, we have 2y squared plus 3xy minus 2y plus 6x dx plus x times x plus 2y minus 1 dy is equals to 0. So let's distribute this one so we can have an easier equation. Now we will have 2y squared plus 3xy minus 2y plus 6x dx plus x squared plus 2xy plus x dy is equals to 0. Of course, first let's test if this equation is exact by using the partial of m in terms of y is equal to the partial of n in terms of x. Now let's first solve for the partial of m in terms of y by using this equation and deriving this in terms or with respect to y. So the derivative of 2y squared is simply 4y, and the derivative of 3xy is 3x, and the derivative of negative 2y is simply 2y. And the derivative of 6x is equivalent to 0. Now let's solve for the partial of n with respect to x by using this equation and deriving this in terms of x. So the partial of x squared is 2x, and the partial of 2xy is simply 2y, and the partial of negative x is simply negative 1. So as you can see, these equations are not exact. So we will use an integrating factor. Since we have two rules, we're just going to use one, and we're just going to use the easiest one. Let's say, for example, let's use this one, since this equation is much simpler. So let's use 1 over n times the partial of m with respect to y minus the partial of n in terms of x is equals to f of x. Now, our n here will be this one. So just substitute that in this area. So we will now have 1 over x times x plus 2y minus 1 times our partial of m in terms of y minus our partial of n in terms of x is equals to fx. Now let's distribute this negative sign inside this parenthesis, so we can have 4y plus 3x minus 2 minus 2x minus 2y plus 1. So let's combine like terms to come up with this equation. X plus 2y is minus 1, wherein 3x minus 2x is simply x, then 4y minus 2y is simply 2y, and negative 2 plus 1 is negative 1. So as you have observed, this is the same and this is the same, so we're just going to cancel this out. So our f of x will be now 1 over x. So our integrating factor, since we've used this rule, we're going to use this integrating factor. I of f, integrating factor is equal to e raised to the integral of f of x dx. So our f of x is 1 over x. So the integral of 1 over x dx is simply ln of x. And using the logarithm of exponent, we're just going to cancel this out. So our integrating factor will simply be just x. Now that we have solved for our integrating factor, let's distribute this here in our equation. We will now have a new set of equations which is 2xy squared plus 3x squared y minus 2xy plus 6x squared dx plus x cubed plus 2x squared y minus x squared dy is equals to 0. Now, let's check if it is now exact by using the partial of m in terms of y is equal to partial of n in terms of x. So, let's solve for our partial of m in terms of y using this equation and deriving this in terms of y. So, the derivative of 2xy squared is 4xy, and the derivative of 3x squared y is simply 3x squared, and the derivative of negative 2xy is negative 2x, and the derivative of 6x squared is 0. Now, let's solve for the partial of n in terms of x. The derivative using this equation. So, the derivative of x cubed is 3x squared, then the derivative of 2x squared y is 4xy, then the derivative of negative x squared is simply negative 2x. Now, as you can see, this one and this one are now the same. So, this equation is now exact. Now, let's proceed to the next step, which is finding the potential function in terms of x or deriving the m equation, which is this one. So we're going to derive this equation in terms of x dx. So any variables aside from x will be moved out of the integral sign. So we will have now the integral of f of x is equals to 2y squared, the integral of x dx plus 3y integral of x squared dx minus 2y the integral of x dx plus 6 the integral of x squared dx. Now, let's integrate this. We will now have f is equals to 2y squared x squared over 2 plus 3y x cubed over 3 minus 2y x squared over 2 plus 6 times x cubed over 3 plus, instead of the arbitrary constant c, we're just going to use an unknown function. Let's use g of y. Now, this equation can be further simplified. So we're going to simplify this. Now, our final function will be x squared y squared plus x cubed y minus x squared y plus 2x cubed plus g of y. Now, let's derive this function in terms of y in our next step. So, the derivative of x squared y squared is simply 2x squared y, and the derivative of x cubed y is simply x cubed. The derivative of negative x squared y is negative x squared, and the derivative of 2x cubed is 0. So, 0, or we're not just going to write that down, and the derivative of g of y is g prime of y. Now, equating this to our n, which is this one. So, copy that. This is equal to x cubed plus 2x squared y minus x squared. As you can see, we have terms here that can be cancelled, which is the 2x squared y, the x cubed, and the negative x squared. Now, our g prime of, now that remains is, all that have remained is the g prime of y is equal to 0. So, to simply just get the g of y, we're going to integrate both sides by dy. So, the integral of g prime of y is equal to the integral of 0 dy. So, our gy is simply negative 0 plus c, or is just c. Now, in this one, we're just going to put this in this value in here. copy this function, then substitute gy to this one. So we will now have x squared plus 2 plus x cubed y minus x squared y plus 2x cubed plus c, or just equal to c, I mean. Since this equation can be further simplified, we're going to simplify this. So our final answer will be x squared times y squared plus xy minus y plus 2x is equals to c. So that is the final answer for our example number 1. Now let's proceed to example number 2. In our example number 2, we have y times 2x plus y squared dx plus x times y squared minus x dy is equals to 0. So let's distribute this. Now we will now have a new set of equations with which is 2xy plus y cubed dx plus xy squared minus x squared dy is equals to 0. So first, let's test for its exactness. Let's solve for the partial of m in terms of y by using this equation and deriving this in terms with respect to y, or in terms of y. So the derivative of 2xy is 2x plus the derivative of y cubed is simply 3y squared. And let's solve for the partial of n in terms of x by using this equation and deriving this with respect to x. So the derivative of xy squared is simply y squared, and the derivative of negative x squared is negative 2x. As you can see, these equations are not the same, so we're going to use an integrating factor. In this time, we're going to use the g of y, or we're going to use this equation, the function of y alone. Let's just substitute this one with Rm, the value of Rm, which is this one. So we will now have 1 over y times 2x plus y squared times 2x plus 3y squared minus the value of partial of n in terms of x, y squared minus 2x is equals to g of y. Then distribute this negative sign inside this parenthesis to come up with this one, 2x plus 3y squared minus y squared plus 2x. Now, combine like terms, we will now have 2x plus 2x is equals to 4x, then 3y squared minus y squared is positive 2y squared. So, let's simplify this so we can have 2 times 2x plus y squared. So, since this one and this one is the same, we're just going to cancel that out. So, all that remains is 2y, or this is the value of our g of y. Okay. Sorry. This is now our value of g of y. Now, let's solve for the integrating factor using this one. So our integrating factor is equivalent to e raised to the negative integral of g of y dy. Now, since we have the value of our g of y, this one, we're just going to put that here. And since negative 2 is a constant, we'll move that out. So that remains is negative 2 is integral of 1 over y dy. So this one, it will become this, e raised to negative 2 ln of y, and using the logarithm rule for exponent, our integrating factor will simply just become y raised to negative 2. Then, now that we have found the value of our integrating factor, or we have found our integrating factor, let's distribute this into our equation. So we will now have our new equation, 2xy raised to negative 1, since 1 since y plus y raised to negative 1 plus, or let's say 1 y, 2xy. So the exponent of y is simply 1. But, so if we're going to distribute that, we will have y y is equal to negative 2 plus 1. So it is equal to negative 1. So this is now our new m. 2xy raised to negative 1 plus y dx plus x minus x squared y raised to negative 2 dy is equals to 0. Now let's test for its exactness by solving for the partial of m in terms of y and partial of n in terms of x. For our partial of n in terms of y, we're just going to derive this equation with respect to y. So the derivative of 2xy minus raised to negative 1 is negative 2xy raised to negative 2. Then the derivative of y is simply 1. So, and now let's solve for the partial of n in terms of x using this equation and deriving this with respect to x. So, the derivative of x is simply 1, then the derivative of negative x squared y raised to negative 2 is negative 2xy raised to negative 2. Now, let's proceed to the next step, which is integrating our m. Just copy our m and integrate this. So, we will now have the integral of f of x minus 2y raised to negative 1. Since this is constant, this is moved out. Then the integral of x dx plus y, the integral of dx. We now have the f is equal to 2y raised to negative 1 x squared over 2 plus xy plus g of y, or we're just going to use the unknown, again, unknown function. So, our final function now will be, our final potential function now will be equal to x squared minus x squared y raised to negative 1 plus xy plus g of y. Now, using this, we're going to derive this with respect to y and equate it with our n. So, deriving this in terms of y, we now have negative x squared y raised to negative 2 plus x plus g prime of y is equal to our n, which is x, this one, or x minus x squared y raised to negative 2. Since this one and this one can be cancelled out, our g prime of y will simply just become 0. And to get that g of y only, we're going to integrate both sides by dy. So our g of y is 0 plus c, or simply c. Now, using this one, copy this and substitute the value of this one to this one. We will now have x squared y raised to negative 1 plus xy plus c, or equal to c. So, since this one, our y here is in negative exponent, we're just going to bring this down. So, we will now have x squared over y plus xy is equals to c. To further simplify this, we're going to multiply both sides by c. So, this one will be cancelled out. Then we will now have x squared plus xy squared is equals to cy. And this can be further simplified again, which is our final answer for this example, x times x plus y squared is equal to cy. So that's it with our integrating factor, guys. I hope that I have delivered the concept of the integrating factor to you clearly, and I hope that you learned something from me. So that's it, guys. Thank you for watching and thank you for listening, and I hope that you will if you have time, please watch our other videos to support our YouTube channel. Okay, so that's it. Thank you, guys, and have a nice day.